One take, everyone knows the rules. So today I wanted to talk about the physical laws and physical constraints that underlies and underpins every single athletic movement that you can think of, okay? This was sort of inspired by a brief conversation with formerly Ben DPT Dunks, now Athletic Doc on Instagram, about the determinants of stride length and many different biomechanical or technical factors that people typically associate with better performance. What is behind all of those? And simply put, the fundamental rules that govern optimal technique and how the best athletes, the best problem solvers move is physics, mechanics, really, Newtonian mechanics for that matter. And that's honestly high school level mechanics applied to the human body. It gives you a lot that you can understand when it comes to human movement and sports performance. A side note, when people mention athletes are excellent problem solvers, obviously that applies in the context of various constraints that comes as part of the sport, right? The rules, the opponents, the defense, offense, the implements, the coaching, the strategy, all of that. But also, they are good problem solvers in terms of finding the optimal solution to maximize a specific aspect of the physics within the laws of physics, okay? The game of life we play, governed by the laws of physics. So let's talk about stride length quickly. One take, all right? One take. So stride length, let's talk about at max velocity, where your horizontal velocity, by definition, at maximum, if you can sustain it, it's constant. It's held as constant. So Ben mentioned a few things that governs flight stride length, like your reach, leg length, range of motion, so how much your leg can swing across in space. And also I think he mentioned horizontal takeoff velocity, which is a bit of a misnomer because takeoff velocity is vertical. So let's talk about it. Max velocity, by definition, as a reminder, means your horizontal velocity remains somewhat the same. It might decrease if you get tired, it might increase as you sort of open up, but once you hit true max, horizontal velocity is the same. So then what goes into stride length? Well, it's a distance metric. So essentially, velocity times time. The velocity is your horizontal velocity and time is your flight time, okay? So because stride length is computed between ground contacts, which is defined by the distance of flight between steps. So what determines flight time? Well, as a jumping research guy, flight time is determined by your vertical takeoff velocity, okay? So in Ben's original post, horizontal takeoff velocity, it really is a bit of a misnomer. What it's really talking about is the vertical takeoff velocity that the athletes are able to generate across each of the ground contacts. And to generate really, really high vertical velocity, you need to apply a high vertical impulse, and you need to generate that impulse in a short amount of time, because there's also a concept called contact time. Because obviously, when you have a lot of high horizontal velocity, every time you contact the ground, you can only stay on there for so long before you ran out of space. You touch down in front of you, your body translates forward, and then you finish off the toe off with your leg behind you. So really the solution for sprinting is maximizing vertical ground action force generation within that small amount of time you have during the ground contact. Well, in that case, it really is about vertical RFD. Even though I don't think RFD is everything, having a high vertical RFD can be a very, very helpful and successful strategy for high sprint speed. So notice how I analyze that a measure that we typically associate as a horizontal distance is actually governed and controlled by a vertical quantity. So this sort of concept is very, very simple and common in mechanics analysis and approaches, because you divide up your directions and look at the directions of forces being applied to you. So in the case of sprinting, the two forces really is the force you apply against the ground and your weight. Air resistance is negligible. So basically, to have a very nice horizontal translation, you actually have to get really good at vertical force generation. All right, I hope this helps.